Okay, so this is kind of like a part 2 of the beginning of how I did it, the how-to of the 4-inch PVC FPV UAV airplane. Over there you'll notice I have the wing. I'll talk about that up close and see some specifics about it, but the heart of it starts right here, and what I'll do is just real quickly demonstrate how I came up with the profile and the size, etc., of the wing that I have. I'm the guy that has, you know, if I don't have to buy it and I can make it, I'm that guy. And I'm a cabinet maker by trade, so my background is finished carpentry. And over here I have table saw, chop saw. I built that table to do mobile on-site cabinet installation for a well-known HD home improvement center, and so I have the skills to fabricate, and I have the tools also. So that's kind of key. Your level of expertise is really dependent on what you can do here. If you know of somebody that has these skills and you can buddy up with them, you can get this project done real easy. It isn't really all that difficult, just that these power tools, specifically the table saw, chop saw, make things so much more precise and easier. So if you can get a hold of those tools and you know how to use them, or they're available to you, then fantastic. If not, you'll end up having to do this by hand cut. Don't know that I would do that, because it's really not going to turn out as accurate maybe as it needs to be. Sure, it might fly. I'm sure it will fly actually, but I don't know, I'll leave that up to you. So anyway, let's get started here. How did I come up with the profile, the airfoil, the cross-section view of that wing over there? Well, the Sedona 46T is the wing profile or airfoil I copied. Hold on just a second. I think I might have the No, it doesn't tell me. I'm looking at the assembly manual. The Sedona 46T, and on the data at the bottom it doesn't really show, and it's not showing the actual airfoil. If I come up with that, I'll figure that out, but it's really not all that important. So the point is, you can find online a foil that you want to use, and all you got to do is reproduce it on paper, upscale it, upsize it to the wing loading dimension estimate that you want. So bigger bird, 12 to 14 inch front to back, front to leading edge, excuse me, leading edge to trailing edge, and then go from there. So if you want something really super thin, faster, looking at a 60-inch wingspan, like an Easy Star or something like that, all you need to do is copy an airfoil and get it on paper. Then from paper you go to a template. Let me show you. Alright, so I have a salvaged wingtip from the Sedona T. The rest of it was destroyed. And I saved this wingtip just for this reason right here. So I chopped it off nice and clean on the power tool, chop saw. And what I did then is, on a piece of like a construction paper, plop that down on there, trace it out. Now I have it on paper. And if you have some material laying around that is like, say, a poplar or a hardwood material like this, you can do it out of plywood. You could do it out of masonite, which is that black, real dense fiberboard, very dark brown. You can find it at any of the Home Depot. All this material comes from Home Depot or your building centers, whatever. The key here is that when you make your template, that if you hang on, if you stall with the wire, you're going to end up with burns. Now, can it burn through the material that you have? And yes, it can on wood, especially if you're going on to the end of the grain like it did right here. So this isn't really a long-term template. So if you want to reproduce this wing several times, I suggest you make this out of a thin aluminum. Go down to your local metals supply and have them cut a piece of, go to their scrap pile and have them cut a piece of any metal. It could be steel, it could be aluminum, and then the next thing you got to do is get it to a bandsaw. Cut this out with a pair of scissors. Cut it out to the outside edge. Remember, the inside edge is the actual profile of the wing. So cut out to the outside edge, a rough cut. Then spray adhesive and attach it to whatever stock you're going to use. Spray adhese that down right there. Then take it to a bandsaw and cut it fairly close. And then fine tune that down with either a flat file or a sanding block, a stiff sanding block. This isn't the right block insert for this size belt, but you can go to your Home Depot or whatever and buy these 80 grit, 120, 220 sanding belts, and they make great flat sanding blocks. Again, on the chop saw, cut a couple of 45s like that, so it's nearly rounded. It doesn't have to be rounded. And then of course cut to length. So you stick that in there, and this block would be longer and it fits real tight. So the point is, it gives you a real nice flat surface to work with. And once you have your template roughed out, you're going to take it down. So if it's a masonite or something like that, then this will work really well. Now you're taking it down till you get to the inside edge. Okay, so enough about that. You get the idea there. You make two of these exactly the same. Okay? So once you make this first one, then take and reproduce this onto another piece of material. You got to have two, right? Because you're going to have one on one side of your foam and the other on the other side of the foam, right? And then the wire rides on top of this template all the way around. Okay, and I'll explain further about that. Alright, so reproduce your airfoil, the entire airfoil, including the aileron sections, the trailing edge. So include that in there. Reproduce it onto whatever material, wood for short term, metals for long term, and then produce two of them that are exactly the same. So you pair and sandwich them together, and then you sand them both to exactly the same. The reason is obvious. If you make one size and the other is smaller, then you're going to have a taper. Now this video or this demonstration is based upon that wing out there, which is a continuous uniform shape plank. We'll call that a plank style wing. There's no taper, neither in the trailing edge reducing or the leading edge falling back, and so forth. So there's no thickness change at all. Now, if you wanted to do that, go to rcexplorer.se, and he has foam cutting technique doing a tapered wing, a double taper. It could be any kind of taper you want. He's made this really nice table jig. It's fairly simple to do. You just need a big flat surface and say a 3/4 inch MDF tabletop to work with, maybe 6 feet long, 8 feet long. Anyway, go there and you'll see his video on how to do double taper or even single taper airfoils. It's just a fabulous way to do it, and you're going to love his website. It's got so much information to help you in doing your own FPV thing. Also, he's got well, a lot about electronics. He's an electronics wizard. All right, so back to this. So now that you have made your foil, your shape, attached to one side, and this particular foam, this source, this is the hard part. You're going to have to be able to find, and this is high density foam. You're going to have to find a source for this, and as of right now I do not have a source. Sorry. So it just so happens that there's a little meat left over on both sides, and I'm going to parallel off the bottom, a little bit of gap there and a little bit of gap here, but I'm paralleling the flat bottom of this wing right here. So that's important too. So if you have one of these on here a little twisted, in other words the tip would be over here, is that you're going to end up with a twisted wing section. The other point is to make is that make sure that you have your space in the front exactly the same. So if you're going to flush it to the front, make sure you flush it to the front on this side. So let's do that. And I'm using 2-inch drywall screws here. Make sure you line it right so the bottom is here. Spacing is crucial here, because you want this panel to be as flat and uniform through and through as possible. Be sure to not over tighten. You're just driving these in until you get a snug hole. It's real simple. And I pre-drilled those holes in my templates when they were sandwiched together. When they were squeezed and sandwiched together, I ran them through with a hand drill bit. You can run them through on a drill press. You get the idea. So verify that your templates are in the right place, spacing is about the same, and so on. So now onto these little bits here in the front. I'm calling these lead-in wires. And lead-in wires is where you're going to drop your hot wire onto and then dive into the material and then go from there. So what I did is I drilled a hole in the front edge, front nose leading edge, and I inserted a piece of push rod wire. Okay, so that's my lead-in wire. Now, David there at rcexplorer.com uses a different kind. This is what I call a positive template, and then he uses negative templates, meaning the actual template is this material space right here, and then there's a hole in the center of the template. And you'll see on his website that he has a split, and his template is actually quite a bit longer. So he has a split in the template for the lead-in, and then he fastens his template here in the scrap material, and he uses foam that is quite a bit thicker, so there's a margin all the way, a larger margin all the way around. This is just what I've salvaged over the years, and I do a lot of that, and I catch a little heck for it. Anyway, so this is how I'm doing this with a positive template. Alright, so now our template's attached, we're ready to go. Now, why this size? Two things is that your hot wire system that you use is dependent upon what you can handle and your space. So I decided to do my hot wire and my wing sections. Okay, we'll call each one of these a section. I made them 12 inches wide each. So in this case, whatever your wing chord is, times or by the width of 12 inches, because it works real easy to set that up, and I'll explain that later. Alright, so this is actually ready to go. So how do you run the hot wire through? Okay, so next step is that you're going to want to hold this down, and you really can't put anything behind it as a stop like this and push against it, because your wires got to come out and this is going to be in the way. So you'll notice too, several people, you've probably seen how to hot wire. There's a lot of tutorials out there on that, and they're all good, I'm sure. Take a weight of some sort that you can find. I happen to have some dead motorcycle batteries here, and this is really all you need. Some people use, like David uses big slug cross sections of steel pipe, or not pipe, steel bar, round bar, and uses that weight. So whatever you can find that's small enough to fit inside of this space. Okay, you don't want it to be in the way. And actually these need to lay down, and I'll explain why here in a minute. Make sure they don't leak if you're using batteries. It'd be best if they're drained and washed out. Safety, right? Okay. So the next step is to get the hot wire on the next thing I'll talk about, I should say, is the hot wire bow. This is a hot wire bow that I made. It looks just like the old school tree saws. Okay? This would be where the blade is for the tree, and they had a tensioning system here. Usually it was a pair of leather strap, and they put it in between and would twist and interlock the twisting stick here, and that would draw tension on this side of this pivoting. Okay, so when I tighten this up, it transfers that energy over here and tightens this up over here. Okay, so what wire is this? This wire is MIG welding wire, specifically a .032 welding wire. Traditionally, hot wire cutting was done with nichrome wire. Nichrome wire is a little bit expensive and may be a little hard to get a hold of. Sorry about that if I was a little out of frame. Might be a little hard to get a hold of, and it's not as durable. This works great. It's fairly durable, and it comes in a roll. Now, if you don't want to buy a $30 or $40 roll, which you can buy at Home Depot, you might go to your local welding shop and see if he'll pull off about 10 feet off of his welding rig to give to you. Basically, it's like pennies, you know, for 100 feet. But the point is, those rolls, there's several hundred feet on there, and it's quite expensive. So anyway, this is what I use: welding MIG wire, .03, and this needs to be fairly taut. So I'm going to tighten this up a little bit more. It's a little bit on the loose side right now, and I do that. I let the tension off. Get a little bit of a sing to it. I let the tension off when I'm not using it. And you can see my pine is giving way to the tension, and it's starting to fracture. So I made a little notch with the table saw, or the chop saw rather, made a kerf cut through it. So I had a locator for this, so it's not going to slip out. Now you can do this mechanically. You can put a flat plate here, and you can put a bolt through here and a bolt through there, and this will still pivot and everything. A little complicated. It'd be nice if this was made out of maple. Maple will not give like this pine. The piece in the center could be pine because it doesn't really have any torsion or any nastiness going on. But there's a lot of energy actually being put on here. So your wire, I used a couple of washers and made a loop through a washer, twist, run it through. Same thing on this end. So what you're going to be doing is attaching your power leads to this wire at some location. It can be on the end if you want, and this bow can be quite a bit smaller. I made this bow because I started doing foam cores in a much wider panel and found how difficult it was, and I didn't rebuild it. So anyway, enough about that, and we'll go from there. Stand by just a second. Okay, so the next component is the power source. In this case, I'm using a car battery charger. Very simple, 23, 25, 30 bucks, something like that. Kragen, AutoZone, local auto parts, online, eBay. There are just a million places to find this. The point is that a 12 volt 6 amp works really well, especially this thicker, a wider panel. You're going to need more amperage. but I would say a minimum of a 6 amp. So 12 volt 6 amp is one of the features on this one. So you have 6 volt 6 amp, and I haven't tried that actually. I should try the 6 volt. I use the 12 volt 6 amp function over here, and it has 12 volt 2 amp. Big Lots, which is Pick and Save, Big Lots now. They sometimes have, they actually usually have a charger back there. And this is a Schumacher model SE82-6, the SE series. Okay, so I'm going to position the power source down here on the ground. I'm going to go ahead and plug it in. Power is on. Now this is where safety is paramount. Are you going to get electrocuted? Yes. If you should be playing with these, there's juice there. It's not a ton, but it is. So what I'm going to do is I'm going to fix one end. I'm attaching one end to the washer on the outside. Okay? I'm going to do it like this. Make sure it has good contact. Okay? So then where we place this wire, or the positive here, will also determine the heat. So we're talking about resistance. So if I put it here, this section will get, say, just for sake of instruction here, let's say it will get super hot at 800 degrees right here at this length. If I move it away, there's more wire here to resist this current, so therefore the temperature will be lower on the wire. Make sense? Closer you are, the hotter and quicker it will get, and that's not changing any settings on your, see now it's red hot there. You don't want that. So you want to be at some distance where, yes, you're going to get real hot, and you also want to sample. Let me take this off. You want to sample on a piece of foam that you have before you get started, and you want to see how well it's going to cut. So I've got a piece of sample there, got my hot wire going. Make sure you have good contact. Really, this should be an alligator clip. This is designed for getting on, clipping onto a car battery post. It's large. It would be best if these were switched out and solder on some small alligator clips that will grab this wire real nice. So, testing the wire. It goes through real quick, and I like that speed. I don't like to go slow. The hotter the wire, the bigger the path, though, that it will cut. And as it cools, the path gets smaller. Okay? So there's your hot wire. That's how that works. And I typically will use a space about 18 inches for these 12-inch sections. Okay? So now I've got my hot wire on there. I've done some samples. Make sure that it's getting hot enough. And then what we're going to do, I'll dry run this real quick. What I'm going to do, and here's another limitation. You see the bow here, and whatever you put on top, this bow, or the brace in the center, needs to be able to pass, be able to get that wire go under, down to the table, and to right over the top and pass over these batteries or whatever it is that you're using to hold it down. You can make up a sand bag, a plastic bag, like a 1-gallon bag of sand, typical play sand, and that would work real well too as a weight to hold down. Okay. All right. So I have to be able to go under. Now I see a problem that I need to correct right now. And that is that because there's so little foam here, that means that I got to get my wire down real close to this table, and that's a little bit of a problem. The height is a little difficult. So take something, another piece of plywood or something, and get it up off the table. Reset your weights. Push-pull on this. Make sure that it is stationary. It's not going to move around. And then I think we're ready to go. Okay. So the speed at which you go through this material will be dependent on how hot it is, and so you just kind of have to play it by feel. All right. So we're going to give it a go right here. It may not work out 100%. That never does. So you're always going to make more sections than you need. Make 3 or 4 more in case you ruin it. So right now it's feeling pretty hot, and you're kind of pulling up a little bit, and this is about the speed it can handle. You don't really want to bend your wire. Don't pull on your wire so much, because it will stretch or even snap. Go along at the speed that it can handle. You'll feel the resistance. I'm pulling up on the template just slightly. And the other next thing that's really important is that you keep the wire 90 to these edges. See, I hung up right there on a spot. Don't worry about that. Keep the wire 90 to the sides of your template. In other words, you got to come out the back at the same time. Very important. So I just did the bottom. Don't move it. I'm going to want just a little bit more heat. So I'm going to go a little closer. Alright? Got a little bit more heat. I might be able to move a little faster. Also, it could burn my wood. So now I'm doing the top section. I'm doing just the opposite. I'm pushing down slightly. And if you miss a spot, don't worry about it. It can be sanded out later. In other words, if you rise up, now you have a bump on the top of your wing, don't worry about it, because when you get ready to join these, you'll take that out